abstract data types, ADTs, represent a way to organize and manage information in programming through abstraction, allowing the definition of a set of values and the operations that can be performed on them without needing to know their internal implementation. In this sense, an ADT encapsulates both the data and the functions that manipulate it, facilitating the creation of more modular and reusable systems. This approach also allows us to distinguish between different levels of data abstraction, from its machine representation to its use in programs to solve specific problems. Furthermore, ADTs are closely related to data structures, since these provide the concrete way in which elements are stored and organized, while the ADT defines their behavior and logical use. Consequently, the implementation of ADTs in languages like C++ relies on the use of classes, interfaces, and structures that separate the definition of operations from their implementation. For example, structures such as vectors, arrays, stacks, and queues allow for the efficient management of data collections according to the type of access required. Additionally, vectors and arrays are notable for their ability to store multiple values in contiguous memory locations, facilitating data access and manipulation through indexing. Furthermore, this organization allows for optimized memory usage and improved program performance. Therefore, abstract data types are a key tool for designing more structured, scalable, and efficient software development solutions.